Outcome 5, non-calculator test relearn. Number 1 says simplify each radical expression. It gives me a square root 64, x to the 6th, y to the 24th. Now, if you don't see an index out front, there is a nice little invisible 2, which means when I start breaking things down, I'm going to be looking for groups of 2. So I'm going to take 64 and break this down. I know it breaks up into 8 and 8, which is probably the best way to break it down because from there I already have a group of 2, so I can circle them. One of the 8s will cross off, and the other 8 gets outside of the radical, so it's no longer inside of that square root. When I move on to variables, what we're going to do is take the exponents, so in this case a 6, and I'm going to divide by the index. So I'm dividing by 2. 6 divided by 2 gives me 3. So that means I have x to the 3rd outside of the radical. I'm going to do the same thing with 24. 24 divided by 2 gives me 12. So I have y to the 12th outside of the radical. Go ahead and try number 2. Here's the work for number 2. The big difference is this time your index is a 3, so I'm no longer looking for groups of 2, but now I have to be looking for groups of 3. Once you break 27 down, you should end up with 3 3s, so those 3s group together, 2 of them cross off, and the 1 3 gets outside. From there, again, we're just dividing our exponents by the index. Number 3 says create your own radical expression whose sum is 9 square root 3x minus 4 square root of y. Your answer must have at least 4 terms. So what I'm doing here is looking for things that add or subtract. Sum means add or subtract to give me this here. So I'm going to start with looking at the 9 square root of 3x, and I'm going to kind of leave these as blank. So I'm going to do blank square root of 3x plus blank square root 3x. What I need to do is think of 2 numbers here that are going to add to give me 9. So I could do 7 and 2. I could do 4 and 5. I could do 8 and 1. I could do 10 minus 1. Anything here as long as these 2 numbers are adding to 9. Notice that we did not change the radicand, so the inside of your square root is staying the exact same. We'll do now the same thing again, looking for negative 4 square root y. So I'm going to put 2 square root y's here. And I needed to add to negative 4, so maybe I'll do negative 3 and negative 1. I could do negative 2 and negative 2. There's lots of different options here, as long as those are adding up to give you negative 4. Go ahead and try number 4 on your own. Number 5 says write the radical in exponential form and simplify your answer. So when I'm going from radical into exponential, your base is going to stay the same. So your x will stay the same. The number that's on the outside, so your index, becomes the denominator of your fraction, and the exponent inside becomes the numerator. So right now I've rewritten this in exponential form, meaning there's no more square roots. My next thing I need to do is just simplify my answer. So 5 and 15 can both be divided by 5. 5 divided by 5 gives me 1. 15 divided by 5 gives me 3. So this here is my simplified answer. Pause your video and try number 6. Here's the work for number 6. Make sure that you have your numbers in the right place and that you have simplified your final answer. We'll go ahead and take a look at number 7 next. Number 7 gives me 2 binomials, meaning there's 2 parts to both of them. They're both in parentheses and there's nothing in between, which means I am multiplying. To multiply binomials, I'm going to do a bunch of distributing, and the main idea with this distributing is that numbers that are on the outside of radicals can multiply together, and numbers that are on the inside of radicals can multiply together. So the first thing here we have is 2 times 1, which is 2. I then have 2 times negative 2 square root of 3. So the -2 and the 2 are both outside of radicals, so we can multiply those, giving me -4. The 3 will stay inside the radical. Next, I have 5 square root of 3 times 1. The 5 and the 1 are both outside, so they multiply to give me 5, and I keep the square root of 3. Next, I have 5 square root of 3 times 2 square root of 3. The outsides multiply, so -2 and 5 gives me -10. And the insides multiply, so 3 times 3 gives me 9 inside of a radical. From here, I need to make sure that I am simplifying anything that can be simplified and combining like terms. So right away I'm noticing that the -4 square root of 3 and 5 square root of 3 both have square roots of 3's, so we can combine those together. -4 plus 5 gives me +1, so I have 1 square root of 3. I'm just going to drop down everything else for just a moment. From here, I want to make sure that everything is simplified. So 2 cannot be broken down, 3 cannot be broken down, and 9's inside the square root. That can definitely break down into 3 and 3. I now have groups, so I can circle my 3's, cross one off. And now this 3 gets out of jail, out of the radical, and it's going to multiply with the 10, giving me -30. I'm going to drop down everything else. Again, I want to look for like terms. 2 minus 30 gives me -28. And I still have that +1 square root of 3. I cannot combine the -28 and square root of 3 because they're not like terms. One has a square root and the other does not. So this right here is my final answer. Go ahead and pause your video to try number 8. Here's the work for number 8. If you got the answer incorrect, please take a minute to pause your video, check your work with my work, and try to find your mistake. Number 9 gives me a fraction, square root of 5 minus 1 over 2 minus square root of 3. The big problem with this problem is that we have a square root in the denominator. My goal is to get rid of that square root. In order to get rid of the square root, we're going to multiply by the conjugate. What that means is we're going to take the denominator and we're just going to change the middle sign. So instead of 2 plus square root of 3, we're going to multiply by instead of 2 minus square root of 3, we're going to do 2 plus square root of 3. If I multiply that on the bottom, I also have to multiply it on the top. I like to put all of these in parentheses here because it helps me realize that I have 2 binomials being multiplied on the top and 2 binomials being multiplied on the bottom. So just like we saw in the last 2 problems, we're going to do a bunch of distributing. So square root of 5 times 2 is 2 square root of 5. Square root of 5 times square root of 3 is square root of 15. -1 times 2 is -2. -1 times square root of 3 is negative square root of 3. I'll do the same thing on the denominator. So I have 2 times 2, which is 4. 2 times square root of 3, which is 2 square root of 3. Negative square root 3 times 2, so -2 square root 3. And negative square root 3 times the square root of 3 is a negative square root 9. From here, we're going to look for any like terms and simplify anything that can be reduced. On the top, I'm not seeing any like terms. Technically, I could take this 15 and break it up into 5 and 3, but I'm not seeing any partners or pairs, so nothing can simplify on the top, so I'm just going to leave it the same. 2 square root of 5 plus square root of 15 minus 2 minus square root of 3. In the denominator, I do have some like terms. 2 square root 3 minus 2 square root 3 cancel right out, and that should happen every single time. Square root of 9 can be broken up into 3 and 3. Again, I have partners, so I group and cross off. this 3 comes to the outside. So in the denominator, I have 4 minus 3. 4 minus 3 is a like term again. 4 minus 3 is 1. And I'm going to rewrite the top part. So whenever you are doing problems like this, we should always end up with just a whole number in the denominator with no square roots. Sometimes you have stuff to combine on the top, but on the bottom, if you did it correctly, you should always end with no square roots. Go ahead and pause your video and try number 10. Here's the work for number 10. If you got this problem wrong, please take a minute to pause your video, check my work, and look for your mistake. Okay, number 11 says simplify x to the 1/6 plus x to the 2/6 and write your final answer in radical form. Whenever I have two things that are being multiplied together and they have the same base, so both of these are x's, we are going to add our exponents. So I have x, and I'm going to take the 1/6 plus 2/6. Because this is non-calculator, your fractions should always have the same denominator, which makes adding these fractions nice and easy. Whenever I'm adding fractions, my denominator stays the same, and I just add across. 1 plus 2 gives me 3. Now I do want to reduce this. 3 and 6 can both be divided by 3. So 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. Now I have combined them, but it says that I want my answer in radical form, which means I want this written with a square root. So I'm going to change this into a square root. The number in the denominator becomes your index, so there's a 2 out front here. The base should stay the same, so it should just be x. And the numerator, the top of your fraction, is the exponent inside that square root. So this right here is my final answer. Pause your video and try number 12. Here's the work for number 12. If you got your answer wrong, take a minute to check over and try to find your mistake. Okay, number 13, the directions on this will most likely say evaluate. There's no x, there's no variable, so I'm not really solving or simplifying. I'm just trying to figure out what 8 to the negative 2/3 represents. So whenever you see something like this, the first step that you're going to do is take this number inside parentheses and break it down. So 8 can break up into 4 and 2, 4 can break down into 2 and 2. So it looks like I'm left with 3 2's. I'm going to rewrite that 8 then as 2 to the 3rd power. There's 3 2's. I'm going to drop down this exponent that we haven't used yet. When exponents are right next to each other like this, they multiply together, which is really nice because these 3's cancel out, leaving me with 2 to the negative 2nd. There's a rule in math that says we cannot have negative exponents, so to change them, we're going to change this whole thing into a fraction. We're going to move the 2 to the negative 2 to the bottom of our fraction, and the negative becomes positive. If there's nothing left on the top, it's a nice little invisible 1. The last thing that I want to do here is figure out what 2 squared is. 2 squared is 4, so my final answer is 1/4. Here's the work for number 14. Go ahead and check your answer. Number 15 says solve each equation and check for extraneous solutions. It gives me 8 plus square root of 2x plus 6 equals 10. The first thing that I'm going to need to do is get the square root by itself. So I want to move this 8 to the other side. To move that 8 over, I'm going to subtract it. It's a positive 8, so we have to subtract. I'm now left with square root of 2x plus 6, and 10 minus 8 is 2. Once that square root is by itself, to get rid of the square root, we are going to square both sides. Since the square and square root are opposite, on this side they cancel right out, leaving you with 2x plus 6 And on this side, we have 2 squared, which is 4. From here, I no longer have a square root, so this should be a nice and easy equation to solve. We'll start with subtracting 6. So we have 2x equals negative 2, dividing by 2, and x equals negative 1. So far I have solved. From here, what I want to do is make sure that I check my answer. To check your answer, we are going to take whatever we got for x and plug it into our equation to see if it is true. So I have 8 plus square root of 2. Instead of the x, I'm plugging in my negative 1 plus 6 equals 10. I'm going to start inside of the square root simplifying. 2 times negative 1 is negative 2. Negative 2 plus 6 is 4. The square root of 4 is 2. And 8 plus 2 is 10. 10 does in fact equal 10, so this is a true equation. Here's the work for number 16. When we solve, we get that x equals 10. Plugging back in and solving, I end up getting 5 equals negative 5. That is not true, so we cross off our answer and we write no solution. Take a look at our last one here, number 17. Okay, number 17 says simplify the expression x to the 6th y over x to the negative 3rd y to the 1/2. Okay, so we're going to start with using some of our exponent rules. We said that if we're dividing and I have the same base, my exponents subtract. So I'm going to write my base of x, and I'm going to do 6 minus negative 3. I'll do the same thing with y's. Now, I don't see an exponent up here, which means it's a nice little invisible 1. So I have 1 minus 1/2. With the x here, these double negatives become a positive. So 6 plus 3 gives me 9. 1 minus 1/2 should leave me with 1/2. So this right here would be my final answer. Okay, here's the work for number 18. This one started off similar where we subtract our exponents, so we get z to the negative 5th and x to the 4/2. 4/2 can simplify to just 2. And then the last thing I need to do is get rid of this negative 5. I can't have a negative exponent, so we move it to the bottom of our fraction and make it positive.